Hello everyone, in this video we're going to go on a completely different tangent, pun not intended, a completely different different path, and we're going to be doing everything in reverse. Okay, you might be thinking, what do you mean reverse? Well, we're going to be talking about anti-differentiation. 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 Okay? And what anti-differentiation is if you're given the derivative of a function, then if you're given the derivative of a function, then if you take the antiderivative, you'll get the original function. Okay? So if you're given 2x as your function, as your thing, going to find an antiderivative, you get x squared. 3x squared, you get x cubed. 4x cubed, if you take the antiderivative, you get x to the fourth. Okay, so it's basically you're reversing differentiation. You're untaking the derivative. Okay, that's basically what it is. Okay, you're undoing differentiation by doing anti-differentiation, by finding an antiderivative. Okay, so a function is an antiderivative. Okay, so f of x, big F, we usually use big F to find antiderivative. So big F of x is an antiderivative if f prime of x equals f of x. So if f of x was your derivative, that means f prime of x would be f of x, is your original function. Okay? So differentiation took you from here to here. This is differentiation. Anti-differentiation takes you from here to here. Okay? Now, there's something I should tell you. For a single function, there's an infinite number of antiderivatives. While for a single function, there's only one derivative. Okay? So you might notice that x squared plus 1, the derivative of that equals 2x. So does the derivative of x squared plus 93. That's also equal to 2x. Constant, the derivative of a constant is 0. This also happens with x squared plus 1 billion. That's also equal to 2x. Okay? These are constant terms. Okay? So if you were to take the antiderivative of 2x, you would have to somehow account for every single constant term. In this case, our constant is 0. Although it could also be negative 1, 1, 2, 3, 4, and so on. So we're only finding an antiderivative. We're not finding the antiderivative because there's an infinite amount. So to generalize this, the antiderivative of 2x is x squared plus c, where c is a constant. A constant. So c's are constant, x squared plus c. And by putting the c, we're basically saying, hey, this c, we're accounting for the fact that there could be a constant term attached to it. And c could be any real number. Okay? And now this lets us have a definitive answer. Okay? So if we were to take the antiderivative of, let's say, 3, then the function who has a derivative of 3 would be 3x plus c. You have to put the plus c so you can account for these constant terms. Now, just like there's notation for taking a derivative, there's also notation for taking an antiderivative. And taking an antiderivative or antidifferentiation, this is also called indefinite integration. Indefinite integration. Indefinite integration. And this is the beginning of our second phase. Integrals. And integral calculus. So integrals. This is the second, perhaps more difficult phase. The integral. So we say that the integral of 2x with respect to x, this dx you have to put there. This is what variable you're integrating. This is your function, and this is your integral sign. You always put this, your integral sign goes over here. And this equals x squared plus c. This is your antiderivative. Or indefinite integral. So the indefinite integral, you can also call it that. You start calling it indefinite integral as we go on, okay? And this, your c, is the constant of integration. Okay. So we have the basics of what it actually is. There is a little bit more rigor to some of these derivatives, but to some of these antiderivatives and more complex integrals, but this is just like the basics, okay? So one thing to know, the derivative of the integral of the derivative of a function is just a function. Remember, these are inverse operations, okay? They're basically opposites, okay? And the derivative of an indefinite integral, I'm saying indefinite integral, so the derivative of an indefinite integral is just f of x, okay? Doesn't mind that c, okay? Doesn't really mind that c because the c goes away in the derivative, okay? So this is, and remember, you have to put this plus c since you're taking the integral, okay? And what we're gonna do is we're gonna learn some basic rules, okay? And the most basic of this is the inverse power rule. The inverse power rule, okay? Okay? So the inverse power rule is, the inverse power rule states that the integral of x to the n dx is equal to x to the n plus 1 to the n plus over n plus 1 plus c, okay? Where n is not equal to 1. We'll cover negative 1. And we'll cover the case where n equals negative 1 a bit later, okay? But know that this is the power rule for integration, the inverse power rule. So for example, the integral x cubed dx, we can just plug into our formula and get x to the 4th over 4 plus c. The integral of 3x to the 5th dx equals 3x to the 6th over 6 plus c, or just x to the 6th over 2 plus c. See, this is not that hard. Okay, and starting next video, we'll focus more on the power rule and more of the basic integration rules, and actually devote more time to solving basic integral problems. If you have any questions, you can comment down below. Otherwise, thank you for watching.